millions of dollars to create those CGI movies, but then you can do the same thing with deepfakes. With this technology getting so accessible, it is having a lot of impact in a lot of industries and saving a lot of money, lot of dollars. But at the same time, like I was saying earlier, it can also be bad, right? There are cases in the past where it has been used for many negative reasons. I have intentionally not put some sensitive reasons over here because I don't want to highlight that. But these are some which I can talk about, like some person getting robbed of his money because someone called a person saying that, yeah, I am so and so CEO and I want this money transferred, and people do it, right? So those are very simple examples. Again, wars, right? Ukraine war, we saw one example there as well. And then there was some video where a fire regarding something was published on the internet, which led to stocks going down for a company. It can have a very huge impact on many people depending upon how you consume the content that is out there. So it gets very, very crucial in the ages going forward that people as us, we do need to have that sanity that when we consume content, we have that filter in our head. We have to have that deepfake detection going in our head. But at the same time, we also need to train the machines to do that, to highlight that, right? So there are companies, LinkedIn, Facebook, and all, right? So these are so vastly used, and they have to make sure that they have these detection models in place. So they are making sure that no negative content is going out there. This is a research from 2024 itself, which says that in the next 10 years, misinformation and disinformation is going to be the second most risk factor globally. And take 3 examples here. Okay, so I have issues with this. Give me a second. Can I project my screen here? Sorry guys, sorry for the delay. Okay. Okay, sorry, I believe my net is not so good. We can do this in the end if we have more time. So this is a website which actually is created by some researchers based on some AI generation models that is called StyleGAN, and where they have data from a real data set and the images generated from their StyleGAN model, which was released in 2019. So basically, like still 5 years old, and that image was from that 5-year-old model. And still 75% of you couldn't detect. Even I couldn't detect when I saw it for the first time. So that's why I took that example. But then you can go and try out more over there. And then this model particularly, like, just give you a glimpse of this, right? What it takes, like, it takes a reference image, and it takes let's say a target format, that what format of positioning that you want in the new image, and then it creates something totally different. It's so amazing. And this was from one of the research projects, or one of the internship research projects in NVIDIA, which came out to be such a good model. And later on, next year, and then next to next year, they generated, or they released StyleGAN 2 and StyleGAN 3. So this is like coolest one I have seen. There are more coming up, but then this started so back early, and the results that we get from here are so good. Now we have many more models which are more video focused, but this is something that is really something that I really liked and wanted to show you guys. The power is immense. We cannot detect, like, whether it is real or fake, and you can, like, I don't know, you can do bad stuff with it plus good stuff with it. So it's up to you. Now coming to the main agenda of the topic, right? So for industries, it's not just about creating deepfakes. They also have to detect those. Like whenever it is wrong, you have to do that detection. And this is, for the talk, I have segregated it into 3 sections. Like, how do you go about doing it? From top to bottom over here, if you can read it through, one thing is do the outsourcing. Second, you can create or have your in-house models. And third is you train from scratch. So whichever thing you choose, you can do it. That's the agenda and that's the motivation for the talk. And if I talk in terms of data science, by the way, can I ask how many data scientists or people in the field of data over here? Okay, nice. That's a good number. Nice. So in this field of data science, if we talk about these three sections, they, if you talk in layers, go from applied data science to research data science. So whichever is your focus, this is what we are going to be covering today. Let's start with outsource. For outsourcing part, I am not mentioning any already available services out there because that's your part to evaluate which one fits better for you depending upon the domain that you're working in. Maybe you are into banking and you want to have like deepfake detection for videos which are talking about content for banking, or maybe some transactions going here and there, or maybe you are into some other industry for, let's say, fashion. So depending upon your industry, you choose the model which fits for you. But then the major thing is common for everyone, that will be evaluation. How do you evaluate which one, which service fits better for me versus not? So we'll talk majorly about that, and to highlight, this is the simplest and low cost, low compute, low storage solution. So we'll start with this. Let's talk about evaluation. And since most of you here are already in the field of data science, but some of you who are not, just to give you a glimpse of this, right? You might have got it already. All we want to detect is whether the image or video that I'm seeing, is it fake or real, which is basically binary classification, okay? In data science terms, it's called as supervised learning. And when we talk about that, particular to this use case, when you are looking into outsourcing, the two major things that you should be looking at, whatever data you provide to those services, is it confidential? It is kept confidential, not leaked out. So data privacy is one, because along with sharing fake files with them, you will also be sharing real content with them, which is confidential to your use case, to your company. So that's why it's very important. That's for you to evaluate and check back with the service providers. Second part is evaluation, which is where data science comes in. Let's talk about data science here, right? So this is a sample data, and which is one of the very beautiful blogs I see. I have reference in the end. So consider this. So this is data where we have 28 fake files and 32 real files. So approximately 50% ratio. And these are like, green ones are like correct detections, wrong ones, cross ones are wrong detections. And when we look at this model, which gave us this output, the accuracy of this model is 52 by 60. So out of 60, 52 were correctly predicted, which is a good prediction, right? 86% is considered good, by the way. We don't need to get 99% like 10 standard students these days. I really, like, it gives me chills how they get 99%. In data science, for binary classification for a problem like this, 86% is good. Okay, that was actually not very realistic when we talk about this particular domain. So in this particular domain, it's not necessary that you will get 50-50% ratio. If you were getting that, probably you were trained yourself to just say, no, go, 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 right? In this particular case, most of the time, 1 out of 10 times you will get a fake, and that will filter with your mind, and you will not be able to do that distinction. So realistic sense, the data is not, so the data is not unskewed. It is particularly skewed where you have less samples of fake and more samples of real. So this is a more realistic example where we have 3 fakes and 57 real images, okay? Now let's look at this, right? Now I have a model, and these are 2 different models. These are the predictions with that. The ones that are marked in red on the left side, and the ones marked in green on the right side, they are the actual fake videos that were there, or fake images that were there. If you look at the accuracy of both these models, right, they both are 95% accurate, okay? Now, can you tell me, out of these 2, which one will you choose? Okay, anyone else? Right one or left one? How many say right one? Okay, hands are slowly going up. Okay, if you're not too sure, the answer is correct. The right one is correct one to choose because before going to the next slide, let me just focus here itself. On the right one, right, where the fakes are there, they are detected correctly, right? And in this one, although there are 7 incorrect detections, they are, all 3 are of fakes, right? So this is, in data science terms, this is what we call as recall evaluation, right? So out of how many fake, which is your, you can say, class of interest, out of how many fakes, how many of them were predicted correctly, right? This is called as recall. In the left one, the recall is 0% because none of them was correctly detected. Right one was, all of them, so 100%. Not realistic because this is very small data. So, but you get the idea, right? So not just look at the accuracy whenever you are talking of a problem of this criteria. Also, just giving a similar example, right? Let's say you have to create a model for detecting cancer patients versus non-cancer patients, right? Same ideology, but that's the thing, right? Apart from looking at just the accuracy, which is generally people ask, right? Oh, what's the accuracy of your model? Doesn't work that way in this thing. So you also have to focus on other matrices. Recall is something which fits best for this. Okay, moving on, right? And before I move ahead, like I said earlier, very low cost, low compute, low storage. You don't need to worry too much. Just go ask someone to do it, but just evaluate that it is doing the right thing for your particular use case. Okay, going ahead, yeah. In-house models. So in this one, we will talk about again 2 things. One is same as evaluation, just a little bit variation here from the past. And the second thing is open source. Like if you have to have your in-house models, it's not necessary that you create it on your own. There are open source things available, which we'll talk about. I've put some examples there which you can start with, and as you explore more and more, you will get to explore more, and please come back to me if you get something much better, right? And for this solution, this is, compared to the past one, this is high compute because you need to have that compute power in your system, but the storage is low because you don't have to store all the training data to train your models, okay? Okay, let's move ahead, right? So these are few open source models that I have listed down here, which we tested. There are a lot more out there. Don't worry about the links and all. I have all the references in the end, so you can scan that QR code later to have all these references, go back and test it out. So this is majorly from 3 different repos. DF40, and then star4, Deepfake, and SRM. I'll talk about very briefly for all of them. So DF40 is like a paper that was released in 2024, where they have 40 different data sets, and they've done like a beautiful job. Because like I was saying, right, a single model trained on one set of data set might not work well with the other. So what they did was, they did that crisscross matching, that train a model on one, test on the other, train a model on the other, test on the other one, right? So they have created so many models that are, and they have provided weights for them as well, and the code for them to run. What else do you need? Best people, right? So thing is, like, if you have to run it, if you have a GPU, very good to start with, but for running it on your local machine without a GPU, you might have to make some tweaks, but it's doable. This one is GF40, so, and in this one, the first one, that is clip large, which is created on all the data sets they have provided. But we'll take a look at that. Like, it also has a drawback. We'll take a look. So there are 3 models we took from there. The second one, STA for Deepfake, I really like this one. It takes a lot of time compared to the others, but it gives really good results. And then there is SRM, which is part of a repo where they have basically done benchmarking on so many models out there. This is something that I've put for example, but apart from SRM, they have many more available. So although I'm showing you 3 references, it's more than 100 references out there, okay? Okay, and if we talk about state of the art, right, the first 2 are from 2024 itself. And there's one more I will refer in the end when we talk about the third piece. And SRM is from 2021, but it gives good results. Okay, so DF40, yeah, I think this is pretty straightforward. Go install, try it out, and models are available. So first time when you try it, and you will have to download the weights and put it in specific folders in your local, and then try it out, right? So out of this, like I was saying, the first model, which is trained on everything, it is of the highest size, 1 GB, right? Rest of them are within few MBs. And sorry. Yeah, this is how the download links look like, the part in black over here, which is like 4 of the models that we have shown there. Actually, 3 of them. Clip is not something I have put over here as part of results. So, yeah. OK, and yeah, this is pretty straightforward. Once you have the setup, you can run it. You might have to, for local version, you might have to make some tweaks. But for GPU, it should work out fine. OK. I'm sorry. OK, and this is the one for STA for Deepfake. Don't worry about the links. The links are there in the end. And this is the 856 MB model. The last one, this is a small one, but works very nice, SRM. OK? And like I was saying earlier, right, if you notice on the right side, they have 34 detectors available. So out of that, we have chosen just one to show like it works. And these are all the assets out there. OK, without wasting much time, this is the SRM detector code in the repo itself. So we didn't do any work there. They already provided this. OK, so this is just an example. So for STA for Deepfake, right, I'm just showing one example because here, what you can do, right, STA for Deepfake, it gives you results per file, per video. But what you can do, like, if you're already working in Python, right, just write a short script to take files from a folder and maybe run the results one by one for each of them and store it in a particular format. So this is exactly what we did over here. And if I just run this file, there are like 5 videos we took. And each of them it runs. And then in the end, it creates a JSON file with the file name and the probability of fakeness for that file. OK? So by the way, this is Home Alone Deepfake, Home Alone file Deepfake, which is a big file, by the way. The other ones are small, small files. So out of this, there are 2 real and 3 fake videos that we posted. So like you saw, right, in the end, there was one file that was coming up. That's the JSON output that you get after everything runs. And this is fast forwarded, by the way. This takes some time. So yeah, don't think like you just click and boom, no. OK, so just to give you a glimpse of what we were talking about, evaluation. Now, once you're done with model extraction, like you have everything set up, what do? You again need to evaluate which one do I choose from, right? Earlier we talked about recall. Very good, right? I think we all got that concept. Now let's talk about this. You have so many options available. Now what do? Actually, maybe not one model will fit for your stuff, what you are looking for. So you can try multiple. And then these are the probabilities of fakeness for the outputs of those 5 files. And depending upon, let's say you have a threshold of, let's say if the probability is greater than 70%, then I actually consider it as fake. So just some thresholding. So with that, this is the output like. So for video 1, 4 out of 5 models said that it was real. In the second one, 3 out of 5 said it was real. And likewise, right? So as you can see, right, I can't say that any of the model is perfect. Actually, one is. Let me highlight that later. But the thing is, what you can do, you can have small, small models created. If you don't want to train from scratch, and you can have a approach like I asked you guys, right, ki which image is real versus fake. 25% of you said that it was, the left one was real, although it was incorrect. I hope more of you said the other one, which could have validated this example. But most of the time, if many people say the right thing, we choose to go with that, right? So this is called majority wins. And this is what you can do. So if I just combine the output of all of them, like I was saying earlier, I actually have 100% accuracy there and 100% recall. This is just a toy example, by the way, just 5 videos, right? It will not look the same with your actual data. But then this conveys the point. Are you guys with me? OK. So with that, let's look at one thing that I was saying earlier. If you look at the accuracy and recall of each of the models, None of them is perfect except the final aggregated one and also this STA for deepfake, right? Then there is another picture that comes into your mind, like how much time does that each model take? That is also very, very, very important, right? So let's look at this. Actually, STA for deepfake, although it gave the best result, you could have gone with just that, but it takes the most amount of time. So there is a trade-off between what you want to pick and what you want to deliver, right? So if I take those 4 models only, it processes everything in less than 2 minutes, and STA for deepfake alone takes 4 minutes, right? So the idea is this, that try to take multiple small models if you are building it in-house and create a majority wins output out of that, which takes you less time compared to, let's say, a very big model. That's the idea of using small models, okay? Okay, that concludes my second part of the talk. Third part, right? Train from scratch. This is the most difficult. I'm still working on this one, by the way. So data set and algorithm, that's all that you need, right? What algorithm I'll use to train my model, what data I will use. So just those two things. And again, just comparing with the previous two approaches, this is the highest compute, highest storage, right? So make sure you have some $1 million in your pocket. Make sure your company approves this, but doable, okay? Again, let's go to the binary classification thing that we started with. Real and fake data, feed it into the model, train it, do the testing, predict real versus fake. Supervised classification problem. All you need is your data and your algorithm, okay? So when we talk of data in this particular section, I will give you references to a lot of public data sets available. But when you are training on your own, you have to have something that is useful for you, not generic, right? Let's say, like I was talking about fashion industry, maybe you have some videos of your own, and if you're doing from scratch, why not do it what fits best for you, right? So the approach basically is take the public data sets, append something of your own, which could be take your private data, get some deepfake creation models. Now we are going to the creation phase, which I think all of us love, right? We all want to say, how do I create my own deepfake or deepfake of my husband or maybe, right? It's fun. I did that, by the way, sorry. Okay, so yeah, so take some private data, take some generation models. I will not give you a lot because I don't want you to misuse this technology. I will just give you some which you can maybe try out, and once you start exploring, you will find more and more. And then create your private data, club it together, and train your model. We'll talk about the algorithms as well. Okay, so these are some data sets. And again, the links for download are available in the end. But then there are a lot of video data sets and a lot of image data sets that are readily available for you. When we started with this research, we were having struggle to find out these data sets. But when we started looking, there are like tons and tons available. There was also a deepfake detection challenge conducted by Meta, where they released this deepfake detection challenge dataset, which is huge, by the way, for images and videos. And one thing I want to highlight in this, right? Not the download part. You guys can go download, do anything, right? One thing I want to highlight is I have listed down the number of images and the number of videos for each dataset for real versus fake. And if you notice, the ratio of real versus fake over here, for example, let's talk about face forensics, right? 1:4. Let's talk about celeb DFV2, 1:10. 1:10 means real is to fake, right? Any guesses why that would be? Why do they do that? Sometimes they have only fake videos or fake images, but any reason why this skewness is there in the data? If you guys are listening to me from the earlier part. Yes? Okay. 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 Anyone else? Yeah, yeah, go ahead.
Would kind of enable the model to understand what features are actually there in the fake models more, so the recall accuracy would be more.
Perfect. Yes, the recall is the answer. Thank you so much. Like we were talking about earlier, right? If you have more and more fake data samples, your accuracy. So even though recall is something now we all understand, some people don't get that concept right. They still ask, what's the accuracy of your data set? That's how you evaluate, right? That's one reason why this skewness is there in the data inherently before you do any evaluation. So even accuracy makes sense for you. Okay? Okay, so we talked about data sets. Let's talk about, okay, data set, my second part was there, right? The interesting part. I want to create my own data. So there are generation models out there. This is not the focus for the talk today, but I am giving you a highlight of, this is very beautifully explained in this DF40 paper that I was talking about earlier. So there are 4 varieties or variations of creating more and more data. One is face swapping, which you might have seen tons and numbers of time on social media, right? Then there is face reenactment, where same face does different stuff. There is entire face synthesis. Again, you might have seen a lot of examples out there. And then there is face editing, right? For each of them, I think the style GAN data that I was showing you earlier, it already captures those 2 things out of these 4, which is face entire synthesis, like a new person comes out altogether, and maybe face editing depending upon the input that you give to it for, let's say, changing the age or hair color or something, right? These are 3 examples here that I have for you, which you can start with if you want to create something for your own. Roop, face fusion, and live portrait. I have a quick example for these. Okay, let's run this, right? So this is for Roop. Like, you can just download it. It's so simple to use. Start it on your terminal, and then it starts this GUI where you can upload 2 files, images or videos. And it runs in few minutes, not hours. And for video, it takes some time. So this is Elon Musk overlaid on some person. He looks a bit realistic, right? Not too realistic, but yeah, it gets the job done. So for video, I recorded this because we didn't have much time for the demo over here. But I think if we have some time, we have? Yeah. We'll do a quick one for, okay. Quick one for Roop, maybe? Okay, guess. How was this one created? सब जानते हैं दोनों को, right? Okay, yeah, you're right. ठीक है. Okay, next one, I actually wanted to do that demo, but I'll skip it because I have some more content outside of this as well. So let me show you this one. I really like this. I wanted to do this live, but I thought if I couldn't, I'll do this, right? This is Elon Musk with his maybe more wise, more older. So this is how it looks like. There are a lot of experimentations I didn't want to show here. So, but yeah, do it at your own time. Experiment, maybe overlay me over Elon Musk or do something. It creates really funny outputs. Okay, so that's not the agenda. The agenda is this. If we have time, we will try Roop, and we will also try the first model that we had. Okay, so detection. This is one paper that I picked up and really like. So we are in this AI/ML track, and we haven't mentioned LLM even once. How can that happen? How can that happen, right? So we have been talking about large language models a lot, and so far we were talking about binary classification. Just tell me real or fake. Just tell me real or fake. Now this paper is pretty interesting. For the first time, they have done this, that don't just tell me whether it is real or fake, but give me a description. Why it is real, why it is fake, what is your analysis? And this is where LLM comes in, and precisely multimodal LLM. So they are trying to feed it with text, like some prompts, and the image or video. And it is able to give you output like description of the image, image description, forgery reasoning, why it is forged or not, and analysis result, like final result, like your binary classification was doing, and then a math score. And okay, yeah, one more thing, difficulty level, like how difficult it is to detect. For example, the sample I showed you earlier, it would have been in the hard category. Okay, and so far it has performed better than any model that we have been looking so far, clipping, exception, right? FFA is killing it. Okay, so internally it is having two phases. One is this fine-tuned multimodal LLM, which gives you multiple outputs, and then that is fed to another model, which is trying to give an output, which is multi-answer intelligent decision system, which selects like which of these answer looks more realistic to me, and it is able to give that really structured output. Like you can, like next phase is just to put it in some JSON format, figure out like what you really want, like fake real as an output, and just use it for your use cases, right? Internally, it has used like 3 different prompt structuring, and depending upon like at what stage you want to use it, and the results are like amazing. So they have compared it with GPT-4o, and they have compared it with one of the open source model, Lava. It is also available on Hugging Face. So, and the result, like for example, these 2 images, they both are fake, but both those other models said that it is real. And in the second one, GPT-4o said, I can't judge this, refuse to judge. People can say that as well, I didn't know that. Okay, so, and this one said, right, yeah, I know that this is fake for sure. And it gives you a description as well, like for example, for the first one, it is saying upon close examination, there are several indicators, blah, blah, blah. The skin texture appears unnaturally smooth in some areas while being overly detailed in others. So I cannot expect me also to do that kind of judgment. So this is, I think, best paper I have read so far. The code is available online. They do say that they have released part of it. Uh, I could find like one of the internal models out there, but haven't been able to replicate it. But the code is out there for training and maybe appending your own data and testing it out. And like I said earlier, high compute, high storage. Okay, so we started with this, and this is what the picture looks like now. As you go from top to down, the complexity increases. Okay, these are the references. Um, I'll make sure that this link is available. I'm not sure if it's public or private yet. But yeah, you can take a picture of this, and all the references that I showed here will be available there. Okay, shall I move on? Okay, I have, I think, 2 minutes. Just this quick one thing we'll do again. Okay, which one is real? Left is real? How many say left is real? Actually, both of them are fake. Okay, but both of them are from real people. This is how this was generated. And I would like to highlight these 2 rock stars who are sitting in the audience already, who are my partners in this research. Thank you so much, Prithvi. Thank you so much, Kathan. Thank you so much. This research is still ongoing, but we all are so excited about what's going on in this AI phase. And I believe, I think, after this talk, you guys are also excited. This is something that I do on a personal level, like the House of AI. We talk about AI ML stuff. There are so many people who, and there are so many things out there that we don't explore on our own, but this is a space where we talk, where we discuss about AI technologies and AI features that are coming out. So I'm happy to invite you all. Please scan this code and revert back to me if you need to talk more. And with that, I close the session and open to Q&A. Thank you.